In special type number 3, let us look at integrals of the form integration of x power m into 1 a plus b x power m whole power p dx. So if you have an integral of this form, you have 4 different cases where you need to do 4 different things. So first, if p is a positive integer, you just need to expand this bracket by using binomial theorem. So if you expand this bracket using binomial theorem, you get a polynomial in x. So if you expand the brackets, you get different powers of x in each term. You can just try to integrate. It's very easy to integrate. Next, if p is a negative integer, and m comma n are rational numbers, then the substitution is you put x is equal to p power k, where k is the LCM of the denominators of m and n. So if m is a fraction and n is a fraction, so we have denominators for the fraction. So take the LCM of the denominator and put x is equal to p power k. And if p is a rational number, instead of being an integer, either positive or negative, if p is a rational number, you need to check m plus 1 by n. So if n plus 1 by n is directly an integer, you just need to put a plus bx power n is equal to t power k, where k is a denominator. And if m plus 1 by n plus p is an integer, then you have to put a plus bx power n by x power n is equal to t power k, where k is the denominator of p. So these are the 4 different cases which can be solved for the integrals of this form. So if the numbers are such that none of these cases work, it's very difficult to integrate those integrals. So if you take the first question, so x power 2 by 3 into 1 plus 2x power 1 by 3 whole power 4. Here p is a positive integer. So in this case, you just need to expand this bracket using binomial theorem and then open the bracket, you get the answer. And in the second case, so if you have integration of x power minus half times 1 plus x power minus 6 whole power minus 1. Here, as you can see, p is a negative integer. So what you need to do is, you need to consider m and n. These two are fractions. So what is the LCM of these two denominators? What's the LCM of 2 and 6? It is 6. So you just need to put x is equal to p power 6. Just need to put x is equal to t power 6 and then do the working. So mostly you get this integral solved. Next, if you go for this integral, here p is not an integer, p is a rational number. In that case, you have to check what is m plus 1 by n. So in this case, m plus 1 by n minus 1 by 3 plus 1 by 1 by 3. That is 2 by 3 by 1 by 3 is equal to 2. So m plus 1 by n is an integer. So you just need to put x plus 1 plus x power 1 by 3 is equal to t power, the denominator of this. So 1 plus x power 1 by 3 is equal to t power 4, you get the answer. And finally, if you have x power minus 11 times 1 plus x power 4 whole power minus half, here also p is a rational number. So first check m plus 1 by n. So m is minus 11 plus 1 by 4 is equal to minus 10 by 4. That is minus 5 by 2. It's not an integer. So now if m plus 1 by n is not an integer, you add p to it. So if you add p, you get minus 1 by 2 is equal to minus 3. So m plus 1 by n plus p is an integer. Then you have to put 1 plus x power 4 by x power 4 is equal to p power, the denominator of p. That is, in this, 1 plus x power 4 by x power 4 has to be equal to p square. So that will be the valid substitution. So what we do now is, let us solve these 4 questions using our general process and let us see how things will work out.